When you are tasked with improving that machine performance and getting to a Six Sigma level, always check your machine capability first. Because if you cannot get your CMK up to a good level, you have no chance of getting your CPKs or your PPKs up to any level or ever reaching that Six Sigma. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today we'll be talking about that CPK, CMK, PPK thing and which one to take first. Well, the title spoils it already. Take CMK first, but let's dive into why that is needed. But before we do that, just a little recap about Six Sigma. So how much spread as compared to your specification limits are you allowed to have to reach the Six Sigma level? And if you just said 3 Sigma, then I'm afraid you're going to have to push a little bit harder. What Six Sigma is trying to do is not to get from -3 to +3, so 6 Sigmas, but in fact we are going to go to 6 Sigmas on either side. And what this does is, 99.7% of our process will be within 3 Sigmas. So if we have specification limits that are 6 times as wide as one standard deviation, we have a very stable process. This is what Six Sigma means, and it is very hard to achieve. Now, this will lead to a CPK of, yell it with me, 2, because Six Sigma is twice the 3 Sigma. By the way, if your process is not centered, your CPK will drop. So keep that in mind. But if you, in your factory, have a process that is, somewhere near a CPK of at least less than 1, right? You will get a message from management. You did your green belt or your black belt training. Go ahead, fix our problem. Then the very first thing that I advise you to do is to take 30 to 50 samples, consecutive samples. To 50 consecutive samples. Why? Because this most but eliminates the random factors around your process. So there is no switching of dies, there is no different material. This is what your machine in normal operating settings can do, you could say, at its best. And this actually is the basis on which we calculate the machine capability, CMK. And from this you will get, several scenarios, but basically one of 2 scenarios. So you either get something that has a CMK of well below 1, because you cannot even stay within the 3 Sigma reach, or you get something that is at least well within the margin. It's somewhere between 1 and 2, maybe higher than 2 if you're very lucky. And this means that at least the machine and the whole process around it at a very short point in time, so when it's just up and running and continuing to do its thing with the same operator and the same material, can reach a normal, a very good, preferably, capability level, or is your machine capability already not able to make it at all? And this will, of course, create very different ways of then looking at the process. And that's why this is so important. If you have your CMK, so machine capability, of your 30 to 50 consecutive samples, you are going to go into a really inside focused way of then attacking the problem. We are looking for deviation sources that are really inside the small process. These can still be machine causes, material causes, some more machine causes, a person doing something, method causes. They can be Still, all over the board, do not think that when the machine capability is low, that it has to be only machine factors that influence this spread. Now, there are really still possible causes in all of our 4Ms, but you do focus on things that are very close to the process, really inside the process, and you can ignore many of the possible factors. While if we have a CMK that is quite reasonable, at least more than 1, preferably closer to 2, we will start to look much more for those outside factors. So these are things that happen between shifts, between material changes, when you do a new setup of the machine, between production batches from day to day. And what you will basically do is you add a lot of possible causes. So maybe, again, there are machine causes. If setting the machine is very difficult and it is different every time with new products, definitely a machine setting. Or maybe some materials are not so good, or we have improper methods of doing our stuff, differences between operators, because now we suddenly are checking for what is happening between operators. These samples were not with different operators, they were with the same operator, the same product. So when we see that that part is well, while our overall CPK, so the process capability, was not high, we are going to look for factors outside of the direct process. Do remember, your CPK can never be higher than your CMK. And that's why this is such a good starting point for any Six Sigma project. If you have any other nice tricks to share with us about using the CPK, CMK, PPK, things that might help us in the community, do drop a comment below. And if you like this video, don't forget to hit that like button. For now, I wish you the best of luck with your Six Sigma process improvements, and as always, enjoy the journey.